Hello and welcome to Digitech. Today we're going to continue on with the Cipher program. So you may notice that it's a slightly different startup to our usual projects. That's because we're continuing on from one that we've already set up. So rather than going to GitHub directly, I'm just going to open up GitHub Desktop because it's already cloned to the machine. So here's our encrypt program from last video. So the function just takes input string from the user and converts it to the respective character codes. So I can't remember what the numbers are off the top of my head. I think the actual numbers, so like 1 gets translated to 49, 2 gets to 50. I think A's and B's and stuff start around maybe 70, something like that. I'm not sure. But basically it becomes unreadable to your average person who hasn't memorized all of the character codes, which, I mean, how many people is that going to be? So now we're going to continue on, and an encryption function is not very good without a decryption function, and that's what we're going to set up now. So I've just added a second button, one that says decrypt on it, and the decrypt button is going to be connected to the decrypt function. So I've just added a console log here so that we can test that the button's actually connected. And because I'm lazy and decrypt, I was finding it difficult to spell crypt every time. I'm just going to copy and paste the function name in there, save any typos. So if I click on decrypt, obviously nothing happens because I haven't written any code yet, but in the console it does say that our button was clicked, so we know at least the connection's working. Then we can see our test word is translated and T represented by 116. Alright, time to write out our decryption function. It's going to be essentially the opposite of the encrypt function, but it's a little bit more tricky because we're not doing it letter by letter. We need to group up those numbers first. So when T got translated to 116, we're going to have to get all three of those numbers, then translate it back. So we're going to have to sort of collect up the numbers in between the pipes and do it code by code. So here we're setting up our variables that we need for this function. The first one is ciphertext. So that's the input, it's the gibberish that we need to translate. Second one's plaintext, that's going to be our output. And we've got a third one there, char code, which is going to represent the groups of numbers. Similar to the encrypt function, we're going to use a for loop to iterate over the ciphertext. Now you'll remember that text in JavaScript is represented as an array, which means you can do a lot more with it. In this case, we can go over letter by letter and group them up. So we're going to do an if statement, and our if statement is going to check if the character that we're looking at is a pipe or not, because the pipe is what separates the character codes. So if we're looking at this particular position in the ciphertext and it's not a pipe, then we know it's one of the numbers that we need to look at. Then we can add that number to the char code. So at the first position, it's 1 in the ciphertext, so that'll get added to char code. And then I think it's another 1, and that'll get added. Then it's a 6, and that'll get added. Then it's a pipe, so we don't want to add the pipe. As soon as we get to the pipe, the else part of our if statement is going to run instead. And the else will take whatever the char code is at the moment and translate it from a char code back into an actual character. And we'll add that to the plaintext, reset the char code back to nothing because we need to start getting the next group of numbers, and the loop will continue on. And the last thing is to update the output to be the plaintext once it's been built up. So it's going to go over that whole string of numbers. 116 pipe, 101 pipe. Every time it's a number, it's going to add it to the char code. Every time it's a pipe, it's going to translate whatever the current char code is back into a letter. And if you copy and paste our encrypted string in, we can decrypt it back to testing. So here I was just testing empty strings to see if they work. Now I'm going to test a set of A's, and that seems to work as well. And I think I started messing around here to see what would happen if I kind of really try and break it. So here I left off the last pipe and it still worked, so that's good. And trying to decrypt just some random letters and stuff, that meant nothing because there was no pipes. The code never actually tried to translate it back. And if I try and encrypt an encrypted string, so like double encryption, it did actually work. So if you wanted to make this a bit more intense in terms of encryption, you could just encrypt the encrypted string again, and that would, translate all the pipes and numbers into their own numbers. And in order to decrypt it, you'd have to decrypt it twice. So now that we've got a working decryption and we've tested it a little bit, we can add an update into GitHub and commit that. So we're just going to describe some of the testing that we've done, and I'm going to describe it specifically. I'm going to say exactly what strings I actually tested it with, including the boundary ones, like empty strings and encrypted strings and strings that were the wrong format, didn't have any pipes in them, stuff like that. Which I guess wouldn't be boundary if it's not a valid string. Like if it didn't have pipes in it, then you would consider it an invalid input. But they all passed the tests. They acted appropriately. They did what we expected them to do. So I'm going to put in that they passed the tests. And that way, if anyone wants to come along in the future and double check my testing, they can see exactly what I tested with. So, as usual, decided to make it look a bit nicer. The buttons were looking a bit generic, so decided to add in the button class. And as with most things in Bulma, the styling classes are the same name as the actual HTML element. So I was looking at this, and after a refresh, you can see it's updated the styling to make it a little bit less generic, more. I don't know if it's stylisher, but it's definitely not the basic. The input does go the full width. If you don't like that, you can style the width to be however you like. But I thought it'd be nice if the buttons were different in terms of color as well. It's always nice for the user to have an indication with color of how the buttons are different. So I used is warning on the decrypt one. I felt like in decrypting was more dangerous, so I used warning. And then I couldn't remember what the green color was in Bulma, but it was just is success. So we've got a nice differentiation between the buttons, so that if the user doesn't want to read, they can just, I guess, remember the colors or try them out, whatever they like. But after some basic styling updates, we don't need to go into too much specifics. With a styling update, testing, you can just kind of change the size of the page and maybe look at it on your phone or something for the testing. We don't need to go through the whole round. Because we haven't changed any of the decryption code, we don't need to do any more testing on that. And then just to check everything, you can have a look at the source code on GitHub and check that our changes are out there. I think the latest ones were those is success and is warning, so they're there. The decryption function's there, so everything's looking pretty good. Most satisfying thing about any project is closing those tabs at the end, and that'll do us for the decryption. Next, we'll have a look at doing some shifting, so it's not a direct one-to-one for the character codes and the letters.